Welcome back to another exciting chemistry lesson. Now we already learned how to use this flowchart and we memorized it already. But there are certain information that's not included in here, and that is density. Where is density? Well, with density is a conversion factor. Remember, density is equal to what? That density is equal to mass over volume. And if you remember, this volume right here only exists because of STP, and then this volume right here only exists when we have all of these factors involved: pressure, moles of gas, the R constant, and temperature. What if we have volume relationship to density? So here we have density mass over volume. So this allows you to have another connection in terms of volume going to mass. So let's solve a problem that works with density, and going from density we get to mass, and then we can now go to anywhere on the flowchart. For example, in this case, bromine gas has a density of 3.0 gram per millimeter, and notice how they write it like this to trick you, right? A chemist used 1.6 millimeter of it for a chemical reaction. How many moles of bromine gas are used in a chemical reaction? So first of all, what is bromine gas? A lot of students get tricked by this because they think bromine gas is just Br. No, it's Br2. All the halogen gas always come in diatomic. So that's number one trick. And then they trick you again by putting this like that, right? You have to realize this is a conversion factor. Okay? Grams equal to 1 milliliter. Or if you just want to write as a fraction, like this way is fine. We have 3.0 grams over 1 milliliter. And this specifically is bromine gas. Okay, so keep that in mind. Now, a chemist used 1.6 millimeter. Okay, well, what of bromine gas? So let's look at this. We have volume. This is your volume right here, right? And the cool thing, this is in milliliters. Sometimes they trick you, they put in some other unit of volume. So guess what you have to do? You have to convert to milliliter because the unit needs to be the same. So our given is what? 1.6 milliliter of bromine gas. And now, again, going back to the flowchart, once you figured out the mass, you can convert to mole. So how do we get volume to mass? Well, the density right there. So multiply. If this is milliliter, so the milliliter is going to be on the bottom. And the top part will be on right there, the gram. So the remainder part, right? So look what happened. Milliliter cancel out. And now once we have grams of bromine gas, we can convert to mole easily. From gram to mole is molar mass. So what's the molar mass of Br? Looking at the periodic table in Br, 1 Br is 79.9. So for molar mass of Br2 is equal to what? 2 times 79.90. So that turned out to be 1598 grams of Br2 per 1 mole of Br2. So this is coming from the PT, okay? So let's go back in here. If this is grams, so the gram part must be on the bottom, 1598 grams of Br2, and then we have 1 moles of Br2. Now let's plug this in the calculator. We have 1.6 times 3 divided by 159.8. And that turned out to be 0.0300. And notice how this is two significant figure, right? SF. So we want to keep our answer in two significant figure as well, which is right there. So we can stop right there, okay? So our answer is 0.030 moles of Br2. And that is our answer right there. We can plug that in here. Now let's go check our answer. 0.030. And then we submit our answer. And there you go. So don't get tricked by extra information. Just go back again, learning how to use your dimensional analysis using the conversion factor. And don't get tricked by basic information like this. Okay? Every time we have a halogen, it's always diatomic. And density, it doesn't matter how they write this. That -1 mean is per, okay? And as always, if you have any question, take a picture of your work, put it in a forum, and we will help you from there. And we'll see you next time on another video.